Hello and welcome. Today, we're digging into the past, but with tools forged in the digital age. For centuries, archaeology and history have relied on shovels, careful examination of artifacts, and deciphering ancient texts. These methods are still vital, but imagine layering data science onto that. That's the core idea behind computational archaeology and history, a field using computers to unlock secrets buried in time. Think about how big data helps us understand markets or biology. Now, apply those powerful analytical techniques to ancient civilizations, historical events, and the grand sweep of human history. It's about finding patterns and connections previously invisible. Researchers today aren't just looking at pottery shards. They're wrestling with enormous amounts of digital information. We have vast databases of artifacts and site locations, digitized historical texts from manuscripts to letters, incredibly detailed satellite and LiDAR scans revealing hidden landscapes, climate records from ice cores, and even ancient DNA telling stories of migration and kinship. Add to that chemical analyses of materials showing where things came from. It's a data deluge from the past. So how do we make sense of it all? That's where the computational toolkit comes in. We use database systems to organize everything. Geographic Information Systems, or GIS, let us map ancient settlements against resources or model travel routes. Network analysis helps visualize complex social or trade relationships, like a historical social network. Natural language processing algorithms can read through thousands of digitized documents, identifying key people, places, or even shifts in language over time. Machine learning helps spot subtle patterns, classify artifacts, or even predict where new archaeological sites might be found. We can build computer simulations, called agent-based models, to test theories about how societies reacted to climate change or how ideas spread. And stunning 3D models recreate artifacts, buildings, or entire sites, aiding research and bringing the past to life virtually. What does this look like in practice? It means using GIS to map the vast network of Roman roads, or analyzing pottery chemistry to trace ancient trade routes across continents. NLP can track sentiment in historical letters, while simulations might model how environmental shifts affected ancient populations. We can create incredibly detailed digital versions of fragile artifacts for preservation and study. By combining archaeological finds, language analysis, and ancient DNA, we can even trace prehistoric human migrations with greater accuracy. Of course, it's not magic. The data we get from the past is often messy, incomplete, biased, or recorded inconsistently. Just because a computer finds a correlation doesn't mean we found the cause. Careful interpretation by experts is absolutely essential. There are also challenges around access to data and tools, and the need for researchers who bridge the gap between humanities and computer science. But the potential is immense. By blending traditional methods with computational power, we move towards a deeper, more nuanced understanding of human history. The future likely involves more collaboration, better data standards, and smarter algorithms. Computational archaeology and history aren't replacing older methods, but enhancing them, allowing us to hear clearer stories from the echoes of time. Thanks for tuning in.